Hello everyone, you have quiz number 4 tomorrow, okay, at 2 p.m. So let me briefly talk about quiz number 4. I'll give you the questions problem from electrostatics, current, electricity, basic magnetism, Faraday's law of electromagnetic induction, reflection of light and refraction of light. So to prepare, please watch my review video for exam 2. I talk about electrostatic, current, electricity, basic magnetism and Faraday's laws of electromagnetic induction there. So please recall that, watch the video again. You do not have to worry about the thermodynamics, vibration and waves. There is no questions from thermodynamics and vibration and waves in quiz number 4, okay, but there are problems from reflection of light and refraction of light. So let me quickly talk about this. So again, please watch my review video for exam 2 and recall the electrostatic induction and recall the Coulomb's law. The Coulomb force is K Q1 Q2 divided by d square, and also recall the electric potential, and then in current electricity define the current I equal to Q divided by T. Q is the charge, T is the time. Recall this formula and also recall the Ohm's law. This is V equal to IR, and under this Ohm's law we also talk about the power P. This is electric power P. This is equal to I times V. Please recall this, and you also recall the series and parallel combination of resistors, okay. So for example, if you have the combination like this, we already talked about this. Let us suppose you have these types of combination. Consider this is R1, you can say 10 ohm, and this is R2, let's say this is also 10 ohm, and this is R3, this is also 10 ohm, and let me call A, B, C here. So what is the equivalent resistance between these 2 points? What is the equivalent resistance between these 2 points, or any 2 points, this and this, or B and C, because they are identical? So if you want to figure out the equivalent resistance or total resistance, net resistance, that's the same thing, you can do this. So it is easy for you. This is positive, this is negative, current flow in this direction. Now look at this right here. Here you have a total current I, but the current divided here, you can call this is I1 and this is I2. So right here there is a division of current. That means this loop, these two resistance and this, the R3, they are in parallel. So this circuit is similar to this. You can draw like this. This is R1, this is R2, this is R3, you connect this to the battery like this. Okay, so all are 10 ohm, 10 ohm, 10 ohm, and this is also 10 ohm. I ask you to calculate the total resistance, or I can also ask you to calculate the total current here also. So first calculate the total resistance. Then if necessary, then you can calculate the total current through the circuit. So now look at this. This circuit and this circuit exactly the same. Then now look here, right here there is a division of current. So here you have a I1, here you have a I2. But look at this, R1 and R2, these two resistors, they are in series, because there is no division of current here. So R1 and R2, they are in series. So first, what you can do is get the total resistance of these two, R1 and R2. How do you get the total? You simply, right here you can write down R12. This is total of R1 and R2 is, they are in series, and if they are in series, then you can write down R1 plus R2. So this is 10 plus 10 ohm. So this is 20 ohm. So this combination R1 and R2, this combination is 20 ohm because they are in series. Now you can replace this R1 and R2 by R12. You can draw the circuit, another circuit, you can draw the other one. Now this is now R12, which is 20 ohm. Now look at this. This R12 and R3, there is a division of current. That means this R12 and R3, they are in parallel. If they are in parallel, how do you get the total? Total is, let's say R1, 2, 3. This is the total, okay? R1, not 1 over R1, 2, 3, just R1, 2, 3. This is the total resistance of the circuit. This is equal to 1 over R12 plus 1 over R3. Or you can write down like this also, R1, 2, 3. This is equal to R12 times R3 divided by R12 plus R3. Okay, then your total resistance R12 is 20 ohm, R3 is 10 ohm, and R12 20 ohm plus 10 ohm. Now use your calculator. How much you get? This is 20 times 10 is 200, 20 plus 10 is 30. So it is 200 divided by 30 ohm. This is the total resistance. So you can use your calculator here, okay? So this is the total resistance, or you can call equivalent resistance of the circuit. Then if one asks you to calculate the current, then you can do this, use this formula, V equal to IR. This is the total resistance. Or what is I then? I is V divided by R. In this case, this R is R123. This is, here you can write down R123 for this circuit, okay? So this is R123. So this must be given, okay? Let us suppose this is 12 volt, for example. This must, the voltage must be, the potential difference must be given there. Okay, so here you can write down 12 volt divided by R123 is 200 divided by 30 ohm. Then whatever you get, please use your calculator. This is your answer, ampere current. So this is how you can calculate the total resistance, and if necessary only, okay, in many cases people, they ask you just to calculate the total resistance. You don't have to, if the question is calculate the equivalent resistance, you don't have to calculate the current. But if people ask you to calculate the current, then you do that, okay? So this is the series parallel combination of the resistors. And similarly, you recall the like magnetism. You can recall the right hand rule. You can recall the like. Let us suppose you have a magnetic field here, and if the charged particle enter into the magnetic field, what happens? It moves in a circular path like this. Okay, and the charged particle, this is charged particle, and it is moving with the speed v. Then in that case, this charged particle experience the force inside the magnetic field, which is the magnetic force. This is B Q V sine theta. So Q is the charge. Okay, so you can think when do you get the maximum force, magnetic force? If theta equal to sine 90 degree, because sine 90 degree is equal to 1. So if theta equal to 90 degree, then sine 90 degree is equal to 1, and you know that sine 90 degree, which is 1 is the maximum value of sine theta. That means the maximum force is only F of B equal to BQV. This is the maximum. So if the charged particle is moving perpendicular to the magnetic field, then in that case the charged particle experience the maximum force. But the question can be asked something like this. Let us suppose the charged particle inside the magnetic field. That charged particle does not experience any force. What happened there then? Charged particle is inside the magnetic field, but that charged particle that does not experience any force. What happened? Very simple. Either the charged particle is at rest means V equal to 0. If V equal to 0, of course the force is 0. Or the charged particle is moving parallel to the magnetic field, because this theta is the angle between the magnetic field and the speed V. Okay, if theta equal to 0, then you know that sine 0 equal to 0. Then if you plug 0 here, everything is 0. That means the magnetic force is 0. What does that mean? That means if the charged particle is moving parallel to the magnetic field, no force on the charged particles. So we already talked about this. Okay, and there is another formula for the current carrying conductor. If the current carrying conductor is inside the magnetic field, the force experienced by the current carrying conductor is BIL sin theta. We already talked about this in the review video for exam 2. Please recall this also. F equal to BIL sin theta. In this case also, if this is a magnetic field B in this direction like this, if the rod is parallel to the magnetic field like this, there is a current in the rod, but it is parallel to the magnetic field. That means theta equal to 0. If the rod is sitting parallel to the magnetic field, no force, because theta equal to 0 and sine 0 is again 0. But if this rod is perpendicular like this, and current is of course passing through this rod, but it is perpendicular. This is the magnetic field, this angle is 90 degree. So in this case, sine 90 degree is 1. That means if the rod is perpendicular to the magnetic field, then in that case the rod experiences the maximum force. Please recall this. And you also recall the Faraday's laws of electromagnetic induction, which is, the statement is the induced EMF, like you have a coil like this, and there is a galvanometer, okay, and you have a magnet. This is a magnet, and there are magnetic lines of force like this. If the magnetic lines of force link with the coil change, then the EMF induced here in the coil, and that induced EMF is equal to negative N delta phi divided by delta T. This delta phi divided by delta T, this is the time variation of magnetic flux. Okay, so the time variation of magnetic flux, that gives you the induced EMF. So if necessary, we can do this induced EMF. This is equal to I times R also, similar to the potential difference voltage. Okay, so this is Faraday's law of electromagnetic induction. The induced EMF is directly proportional to the rate of change of magnetic flux, and it also depends on number of turns, and this is equal to the number of turns in the coil. How many loop you have? 1, 2, 3, 4, like this, like 3000, 4000, 400, 200, something like that. So if you increase the number of turns, your EMF induced. If EMF induced and if your resistance is constant, then current also increase. So please recall this. You need to know this for the quiz number 4. Okay. Then there are few questions from the reflection and refraction. Reflection is simply to have a plane mirror. If you have a plane mirror, then suppose this is a ray of light coming from the source. Here you can call I, you can called O. This is the point of incidence, and right here the ray of light get back to the same medium. This is called as the reflection of light. And here this is your theta I, angle of incidence. This is your theta R, angle of reflection, and we know that theta I equal to theta R. This is law of reflection. Angle of incidence equal to angle of reflection, number one. And number two is the incident ray IO, reflected ray OR, and the normal, you can write down ON. All these three rays, they lie on the same plane. In this case, they lie on the plane of the board here. Like, then you can think also like this. Let us suppose you have a plane mirror, two plane mirrors actually, two plane mirrors. The ray is coming like this. If only, let's say 90% reflect, 90% of the ray of light reflect from here, 90%, 10% absorb there. So this is incident ray. Right here the reflection takes place, but only 90% light reflect. Then here also 10% light is absorbed there. So how much light reflect right here then? You can think about this. Look here, incident here, light reflect, but only 90%. The only 90% reflect. 10% absorb there. Now here, another 10% absorb. 10% of this 90% light is absorbed here. So how much left? Think about this. Okay, it is a reflection and it is not a very big deal. Please do this. And law of reflection. And another thing is, if your height is like 6 feet, if you are 6 feet tall, what is the minimum size of the plane mirror so that you can see your full image? Minimum size. Okay, so I think I already mentioned that if you are 6 feet tall, the minimum height, minimum size of the mirror is 3 feet. We can prove that also. Okay, but right now you don't have to prove this. Please keep in mind, if you want to see your head and your both feet, I mean your head to your feet, if you are 6 feet tall, you need 3 feet tall plane mirror. Okay, please keep that in mind. And we also talk about the refraction of light. Refraction of light. Okay. So before defining the refraction of light, you need to know the index of refraction. Index of refraction is simply denoted by N. This is index of refraction. Index of refraction is C divided by V. Index of refraction is C divided by V. C is the speed of light in a vacuum. Okay, C is the speed of light in a vacuum. So here C, this is approximately equal to 3 times 10 to the power 8 meter per second. You need to know this. This is not given. Okay, but V is the speed of light in any medium. V here, this is speed of light in a medium, whatever medium given, like water, glass, whatever given. Okay, so this is the index of refraction. It is the ratio of speed of light in the vacuum divided by the speed of light in the medium. So meter per second divided by meter per second, no unit, it is dimensionless quantity. Then the refraction of light is when the ray of light travels from let's say here, this is here, we call optically thin medium, with the water. Water is optically thick medium. What happens? Look, at this point the light bent here. So the bending of light when it travels from one medium to another medium, that is called as the refraction of light. And here this is your incident ray, this is your point of incidence, this is your refracted ray. So this angle you can call theta 1 and this angle you can call theta 2. This is theta 2. Then you have a Snell's law. Snell's law is n1 sine theta 1 equal to n2 sine theta 2. This is Snell's law number 1. You can call law of refraction, first law. The second law is, if the ray of light travel from air to water, we call optically thin medium to optically thick medium. This refracted ray, it bends toward the normal like this. It comes closer to the normal this way. It comes closer to the normal. But another one like this, if the ray of light is traveling from, let's say, water to air, then in this case the ray of light travel away from the normal. It goes away from the normal. Again, if the ray of light is traveling from optically thin medium, that is air, to the optically thick medium, that is water in this case, if the ray of light travel from optically thin medium to optically thick medium, it bends toward the normal. And if the ray of light is traveling from optically thick medium to optically thin medium, it bends away from the normal. That means, look here, what happens is, if you calculate the index of refraction of air, index of refraction of air, you can write down simply 1. It is little bit more than 1, but simply we use 1. But index of refraction of water is 1.33. So light bent more if the index of refraction is big. Light bend more. The bending, more refraction here. So because look here, it bend. Now if it is like what happened in case of, let's say, this is water and there is a glass. Water has a index of refraction 1.33. Index of refraction is also called as the refractive index. Okay, water has 1.33 and glass is, let's say, 1.5. And if the light is traveling from water to glass, what happened then? It bent toward the normal or bent away from the normal? This way or this way? What do you think? A or B? What do you think? Because in this case, look, water 1.33, glass 1.5. So this is optically thin medium as compared to the glass. Glass is optically thick medium. So in this case, answer is B. Ray of light bent toward the normal here, like this. Okay, like this. So if the ray of light is traveling from optically thin medium to optically thick medium, it bends toward the normal. If it travels from optically thick medium to optically thin medium, it bends away from the normal. Okay. Now, let us suppose there are two media. One is water here. This is water. And there is a, let's say, normal, and light travels from water to air like this. And I already mentioned that it bends away from the normal like this. If you increase this angle, let us suppose another ray. This is I1, R1, this is point O, this is N prime, this is N. Now this is I2. Let us suppose, you know the I2, it is also traveling from water to air. Now if your angle of refraction is, let's say, 90 degree here, this is your refracted ray, this one, R2. R2O N prime, if this angle is 90 degree, angle of refraction in optically thin medium is 90 degree. Angle of refraction, not incident, angle of refraction, this angle is 90 degree. If this angle is 90 degree, the corresponding angle of incidence right here, this angle is called as the critical angle theta C. This angle is called as the critical angle theta C. So if the angle of refraction in optically thin medium is 90 degree, then the corresponding angle of incidence in optically thick medium is called as the critical angle. And the different transparent medium, they have a different critical angle. For water, I think it is 48.8, approximately 49 degree. for water. Now the concern here is, if your angle of incidence is greater than theta c, let us suppose this is I3. Now look, this is a critical angle, then of course this angle is greater than critical angle, then this angle I3ON, this is I3ON, this is angle of incidence, and this is greater than theta c, critical angle. What happened in this case then? In this case, the ray of light get back to the same medium. So what happens is, it goes like this. This is your R3. Light reflect back to the same medium, and this is called as the total internal reflection. If your angle of incidence is greater than the critical angle, in that case, the ray of light get back to the same medium. This is called as the total internal reflection, and total internal reflection obey the law of reflection. That means angle of incidence is equal to angle of reflection. Okay, so I think this is all. So please watch the YouTube video, watch the review video for exam 2. I think you are good to go for quiz 2. Okay, thank you.